Okay. So, just to comment on one of the homework problems, I'll do that in the summary, but
They are the other asymptotes, not perfect. Other asymptotes are in behavior characteristics. Asymptotes are only ones that cannot be.
properties of exponential functions include the following.
I wish somebody forgets. All right, it's actually kind of easy. No, I was waiting for somebody to care. Here we go. Easy to tell. And it's frighteningly easy to tell. If you have a function, a rational.
Okay, ratio of value to slope is the same at every point. Okay? Doubling time is invariant.
Alright, let's say I had a nth degree polynomial on top and a nth degree polynomial on the bottom. This may seem a little bit vague. I'll clarify momentarily. Are you ready? Okay. Actually, let me be more specific. Let me be more specific.
Interval required to double is always the same.
X to the n plus
Okay.
x to the n minus 1, x to the n minus 1, da 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 da. Like we had the other day.
And actually, if this is true,
And then I have an a
this always has to be true. If this is true, this always has to be true. Because if either of these is true, the function is exponential.
Doubling time is, did you say doubling time is invariant?
Invariant.
in
Doesn't change. Okay?
on the bottom. Are you with me?
Now there are ways I can state this with using function notation, but I want to take a little time to make sure we understand function
First of all,
notation.
what if
Okay.
n and m
Now,
are equal? What the degree on top is the same as the degree on the bottom, like right here. Second degree on top of second degree, right? Okay. Then your horizontal asymptote, if that's the case, horizontal asymptote
okay, a property
is
of power
y
functions, they have more than one property,
n over b sub n.
but this is something we'll kind of take to be sort of a defining property. Okay, property of power functions is
Here,
that
where is this horizontal asymptote? Y equal 3/4. That's it. See the 3/4? See where it's coming from? Where the 3/4 is coming
if
from?
x doubles,
Coefficient, leading coefficient over leading coefficient.
the y values,
It only happens when the degree is equal to the degree. So the horizontal line that graph will hug really tight at its far ends is going to be the horizontal line. If it's not, well,
the y values are always in the same
the
ratio.
degree on top is not equal to the degree
Okay.
on the bottom, then maybe.
Now, it might need a little clarification because that's not a completely unambiguous statement. So let's see what I mean by it. Okay.
Let's do it in other words.
Can somebody give me an example of a power function?
N is smaller than m, meaning big
Okay.
power on the
What
bottom,
functions
small power on top, right?
did you learn to graph?
Y equals x, I'm sorry, y equals b.
Okay, well,
Equals a squared plus b.
remember I don't have the hearing aid in, I gotta fix that. Oh, no.
Quadratics, formulas for lines, slopes and cubes and squares and.
Yeah, cubes, squares, reciprocal function, right? Okay, exponential, just a 2 to the x function, right? Okay, now the one that we love the best is the e to the x function, okay? Because for the e to the x function, this ratio of value to slope is 1. Slope is always equal to the value, okay? Which is a unique property of the e to the x exponential function. What that has to do with 1 plus 1 over n raised to the n, which incidentally I did a good job with. It's not a particularly difficult problem, but it should have gone in. I've had 2 surgeries in this shoulder, so sometimes it's stiff and causes things to miss. If I ever miss, that's the reason.
Uh-huh.
Okay?
Of course, to be a star basketball player.
Huh?
To be a star basketball player.
No, but on my good days, you would want to guard me. And you'd want the ball in my hands a lot because I dribbled off my foot all the time. I had the disadvantage. I grew really tall up to about age 13, and then I stopped growing. Well, you know, we had a basketball team. We traveled into town, played at the Y, won some games, lost some games. We were fairly okay. And I learned to play center. I was a good center because I was taller than anybody else. Okay? Then everybody caught up to me and went past me, and I wasn't as good a center anymore, although I could play the position. I mean, so I never could adapt to another position. Didn't have to do a lot of ball handling at center, so I never became a good ball handler. Probably don't have the coordination to be a good ball handler. So, was I a star? No. Was I barely adequate in a pickup game? Yeah. Okay. And I could shoot reasonably well. Okay. And I still don't know whether I was any good at defense because it's hard to tell. Okay. I was better at football and I was a pretty good golfer. Okay. So anyhow, this is on camera, so you know. Okay, if x doubles, y values are always in the same ratio. Now, I was about to say what I mean by that. So we know that we have functions. So let's just take, okay, most of the functions that you learned about are power functions. Okay? So let's see, power function. You're familiar with it. It's that ax to the p thing, right? And your basic functions that are power functions. Well, what about y equals x squared? Is that a power function? Is there numbers you could put in for a and p that would make this y equals x squared? What would you put in for a? 1. And what would you put in for p?
2.
Okay, so y equals x squared. Okay. And what about y equals x cubed? Well, there's p equals 3, right? Okay. Now there are 2 more at this point. What's another one to be a power function?
Could it be a to the b parentheses to the power of c?
I'm sorry. Again,
A to the power of b, and then all that to the power of c.
to the power of,
I don't know, I'm just doing what I saw from the video. Is that what we're doing?
Yeah, well, those are your rules of exponents. I'm glad you wrote those down. I'm glad you're thinking about them. But that doesn't necessarily answer this, okay? Well, I'm saying that, what are some of your other functions?
Quartic.
Huh?
Quartic.
I don't know what's the matter, because I got one hearing aid in. What, again?
Quartic.
What's she saying?
Y equals ax to, sorry, y equals ax to the fourth. Is essentially what you're
Okay, yeah, but that's not one of the functions that I asked you to graph. You could do it. You make the table same as you do for the others, right? Okay, but what are some of the other functions that I called basic functions? Or basic,
There's 1 over x.
again?
1 over x.
Okay, well, how about 1 over x? Okay, well, what's your value of a? One. Okay, agree. What's your value of p?
-1.
Yeah, p equals -1. Okay? P doesn't have to be positive. It doesn't have to be an integer either. Okay? Like if p is 1/2, that's a power function, right? And what does x to the 1/2 mean?
Square root.
It's a square root. Why is it the square root?
Is the power over the root.
I'm sorry, Maureen.
Because if the exponent 1/2 is power.
Where did we get -1?
Well, it is, but why?
To get y equals 1 over x.
Well, what do you get if you multiply x to the 1/2 by x to the 1/2? Laws of exponents. What do you do with the exponents? If you multiply two numbers with the same base and different exponents, you add the exponents, right? And of course, you got to really know this. And you got to know it in order to do the task that I set for you, which is evaluate these things, right? Okay? So if you multiply x to the 1/2 by x to the 1/2, you get x to the 1, right? In other words, what two numbers do you multiply by, what number do you multiply by itself to get x? Square root of x. Square root's what you multiply by itself to get the number you're looking for, right? Okay? So anyhow, that's why the 1/2 power is the square root. Because if you multiply the 1/2 power by the 1/2 power, you get the power 1. That's what makes it the square root. It's not because it was handed down in the stone tablet. It's not because that's a habit that your algebra teacher used. Okay? And we all do. Not they, I'm one too. Okay? So you get used to it, but you also connect it back to the basic principles, the basic definitions, basic axioms, rules, and so forth, okay? And there's a very simple reason. It's just the laws of exponents. It's what the laws of exponents dictate. Okay, anyhow, you got y equals 1 over x, a equals 1, p equals -1. Okay? What's another one?
1 over x squared.
Yeah, 1 over x squared. A equals 1, p equals -2. Okay? Now, it isn't one of the list of basic functions you have, but it will be because we're going to expand the list to inverse functions. But we're probably not going to do that right now. Also, the 1/2 power is the square root. I remember the pendulum. What power did we have for the pendulum? What was our exponent there? You might want to review that a little bit. But it was a -0.5 power for the frequency. Okay? I mean, we came out with negative 0.507, I think, and I think it was dumb luck that we came that close to negative 0.5 with an actual pendulum, okay? But also, I think we had pretty good data. So, you know, if we did it again, I think we'd still be pretty close to negative 0.5. Usually it comes out a little higher, you know, the number's a little more than 0.5, okay? Like negative 0.56 or something like that. Okay, well anyhow, that's what we have. So I put this in a different color because it's not one of the basic functions that we have now, but we'll expand that probably tonight when I have you do inverse functions. Matter of fact, I'm going to do inverse functions quick. Just to tell you real quick how we do this. Because it's so incredibly simple. Okay, so now this is not a power function. Okay? This is an exponential function, right? That's something you're already familiar with because you've done curve fitting with it, okay? It's y equals a b to the x. And that applies with compound interest problem and population problems and a lot of problems, okay? And you know, if you've got 2 points on a graph that fit this, you can find the values of a and b.
I can't see what that says. I can only see
Yeah,
the
no,
blue
it's not writing real dark, but it says a, b to the x. I think it's because I'm writing uphill, so I got to remember to shake this thing once in a while. You see that?
Yeah.
Is it the glare on the board or what?
It's the color.
Well, I'll switch colors on you.
Is that y equals 2 to the power of x?
Yeah. Okay, so, here. Okay? It's y equals a, b to the x. And here, b equals 2, a equals 1. Now you should remember that when you have an ax to the p, a power function, and you try to fit your 2 points, you get to the point where you got to solve for p, but p's in the exponent, right? And I said, well, you got to use logarithms. And some of you know about logarithms, some of you don't. I gave you a rule for using the logarithms, so we're not going to worry too much about it. Okay, but eventually we'll worry enough about it to be able to use it. Fair enough? Okay, so let's tie that in with these ideas. I can walk over here, move that out of my way without killing myself. Okay? So, we do our table. Now, what are our values of x?
-2, -1, -1, -0, 1/2,
Right. Now, when I ask that, if you didn't instantly know, you don't know what you need to know well enough, so make sure you do. Okay? I mean, you should be able to instantly write down this whole table. Not by memory, but by understanding what you do. Okay? So, if x is -2 for the function y equals 2 to the x, what's y? Yeah, well, it's 2 to the -2, right? So let's just write it out to make sure we understand. This is 2 to the -2. And how do you do 2 to the -2? I don't know if these things are any good. 2 to the -2, I like the way they come out. Seems to be plenty of liquid in here, but I've been shaking it. Okay, so 2 to the negative 2. How do you evaluate 2 to the negative 2? You use the laws of exponents. A to the negative b is 1 over a to the b, right? Something you should be thoroughly familiar with, because you certainly do this from Algebra 1 on, right? So you want to be sure you know this. So this is 1 over 2 squared, which is 1/4. Notice, I'm trying to impress you. I did that without using a calculator. Are y'all impressed? You should be, okay? And impress me by doing these things without a calculator. They're very simple, right? There's no arithmetic here you can't easily do in your head. And when you get to a point where you got to do arithmetic you can't do in your head, that's what the calculator's for, okay? And I emphasize again, keep the calculator out of your hands unless you really need it. Stretch yourself a little bit. If you think, gee, I could do that, but I'm just going to use a calculator, well, maybe if you're in a hurry, you got 84 problems to do in 10 minutes to do them, maybe you're going to do that, okay? But in this course, you should take the time to do the mental calculations. Anyhow, you get 2 to the negative 1, which is 1 over 2, that's just 1/2. 2 to the negative 1/2, what do you do about that?
Put the 1 over the square root of 2.
Okay, it'd be 1 over the square root of 2.
But then you have to put the square root on top and make it square root of 2 over 2.
Okay, that's a square root of 2 over 2. How are you going to figure that out?
Multiply by the top and the bottom by the square root of 2. So
Well, then you get 2 over 2 square root of 2. You're never going to get rid of that square root of 2. What are you going to do about the square root of 2?
multiply the top and the bottom by the square root of 2. And square
Well, we
root-
did that here, because that's how we got this.
Yeah.
And there's no point in doing it again, because you're going to, and then you would end up with a square root of 2 in the bottom, right? And then you do it again, you end up with a square root of 2 in the top, and you never get out of the need to know what the square root of 2 is. Do you know what the square root of 2 is? Exactly? Anybody know the exact value of the square root of 2? Nobody in the universe knows the exact value of the square root of 2. It's an irrational number. There's no end to it. Okay? And one principle with these functions is we only use exact results in graphing these things, meaning we only use results we know 100%. Okay? This is irrational. We omit this. We just don't even do that line for the exponential function. Okay? And what's then, if x is 0, what do we get?
1.
Because 2 to the 0 is 1. I don't have time to go over the fact that there's a reason for that. Also, the laws of exponents wouldn't be consistent. Although some people say that a little differently. Okay, but 2 to the 0 is 1. Any number to the 0 is 1. Make sure you remember that. Don't make the mistake of writing down 0 here. It'll make your graph look really weird. Okay? It won't have the properties of an exponential function. Okay? It's going to go up like this, and it's going to dip down here, and then it's going, yeah, it screws it all up. Okay. And we omit this one because it's irrational. For 1 we get 2, and for 2 we get 4, and then we can easily sketch the graph, right? Okay? So that's just a, you want to understand all these functions. There are other situations where you can't evaluate the function exactly, some where you can't evaluate it at all. What's one example of one of these functions that you can't evaluate at one of these points?
2 to the 1/2.
2 to the 1/2. Well, we don't have any half power functions, and the square root isn't included here. I'll do that one in a minute. there are two important inverse functions, and then once you've got that, you kind of understand inverse functions. I mean, there are a lot of them that, you know, most of them are important, but the two kind of central ones. Okay, so my point is, you're evaluating x squared. Is there any one of those numbers you can't plug in and square? Can you give me the square of every one of those numbers? Sure. What's the square of 1/2?
1/4.
1/2 times 1/2. Now again, you have to know the arithmetic of these. When I say come in here really knowing this stuff, you should be able to answer that instantly because you've worked it out and you've written them out and you've done the calculations and you know how the calculations are done, you know what the rules are. It's very simple, it's just simple arithmetic, but you got to be careful, okay? And also that's arithmetic of fractions, and we put calculators in people's hands to avoid having anybody know anything about fractions. So you got to correct that, okay? And, yeah, I mean, y'all are pretty good with fractions, but you understand you're not as good as you would be if you hadn't bypassed the whole subject from the age of 11 on, okay? If your curriculum hadn't caused you, and it's a direct cause. Fractions are extraordinarily important. Okay. Okay, I'm going to tell you what an inverse function is. So here's our table. For our basic exponential function, y equals 2 to the x. I just omitted the whole negative 1/2 and 1/2 line because we can't evaluate it, and we know that. Okay? Now don't omit that line for the x squared function because you can square 1/2 very easily. Okay? And it's an important point. It gives you the idea, it gives you the shape of the function as opposed to the shape of the x cubed function, which is somewhat different. Okay? Even in the first quadrant. Okay, well, again, we get 1/4, 1/2, 1, 2, 4. What's the doubling time for this function? The doubling interval. On what interval does the value double? 1. Every one of these numbers is the double of the one before it, right? You want to think about that. And the interval, the x interval that causes that to happen is always 1. X always changes by 1, this doubles, right? Okay? So there's our table for y equals 2 to the x. Table for the inverse of this function. Anybody want to speculate on what the table would be?
2, 1, 0, -1, -2 for the x.
Now turning it upside down doesn't change any of the values necessarily. Now if you turn these upside down and use the same values, now if you reverse the order of these and use the same values, okay? It turns out you get 2 to the negative x. So that's not a bad idea, but that's not what we mean by an inverse function.
1 over 2 to the x.
Now that'd be reciprocal, but that's also a good idea.
Oh, wait.
Switch the X and the Y.
That's what you
I'm sorry?
Just switch the X and the Y.
I must have slept in that ear again.
With the X and the Y switch.
Yeah, exactly. You switch the x and y values, okay? So you just reverse these things. You do the -2, -1, 0, 1, 2 here, and you do 1/4, 1/2, 1, 2, 4 here. Okay? Now in a minute we'll stop and I'll ask you to sketch a graph of this. Okay? But there's one more. And of course, I could do this for any of the basic functions. I can switch the columns, right? So there is our table. Well, there's the x values, and the y values are really easy. There are the values of the x squared function, okay? The basic values, the values that we use to get the shape of the function, okay? So, write down the table for the inverse of y equals x squared, and then graph each table. You got 4 tables. Graph this one and this one, then graph this one and this one. See what you get.